Assalamualaikum warahmatullahi wabarakatuh, and hello, I'm Wan Izati binti Wan Hanafi and my group member Nur Syafiqah Suhainuddin, Nur Syafiqah Shaharuddin, Ammar bin Omar, Nur Atika binti Roslan, and Muhammad Al-Hakim bin Harun. We are from group 8 and we will present our project about robot coin collective problem. So before we proceed our presentation, I want to say thank you for our lecturer, Dr. Khairina Airin Fariza Abu Sama. So, for the introduction, dynamic problem is defined as breaking down an optimization problem into subproblem and combine the solution of each overlaid subproblem. It follows divide and conquer methodology. So, optimization problem are those problems that seek the maximum or minimum solution given certain constraint because it do not recompute the solution of subproblem that already been solved. So, to understand more about this, let's dive into an example of robot coin collection problem.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syafiqah binti Shaharuddin. So, I'm coin collecting problem. I'm not going to read a whole problem. Let's explain it. There's several coins that place on a few cells on the NNM board. So we assume that a robot on the left side above at the column 1 and 1, and the robot should collect the coins on each cells as much as it can and reach to the target location, which is on the column 6 and row 5. However, it has a few instruction and restriction. It cannot move like randomly and arbitrarily. So on each steps, it can move like either one cell on right or one cell down from its current location. So it can move like I-1j and ij-1, for example. And let's just say that the target size is I and j. So it can only move between those two.
And I'll present for the solution part of the robot calculation problem. Okay, this is the question for the recent slide. Okay, let us consider row by collimator in which 0 are represented by empty cell and 1 are represented by cell that have coin. Okay, if the coin are coming from the left, this is the formula we use. And if the coin are coming from the above, this is the formula. Okay, therefore, we compare the maximum value between the two cells and sum up with the cell that have coin. Okay, the cell that have coin we assume as 1. Okay, here, we need to compare the value from the left and from the above. Okay, since we can know that the robot can come from the left and can come from the above. So, compare the two values. 0, no cell here, it becomes 0. And also there is no coin here, so it becomes 0. And 0 compared with no cell here, it becomes 0. 0 compared with no cell here, it becomes 0. And 0 compared with no cell here, it becomes 0. And 0 compared with no cell here, it becomes 0. And plus the coin here, it becomes 1. And 1 compared with no cell here, it becomes 1. And 0 compared with no cell here, it becomes 0. And 0 compared with 0, it becomes 0, and plus coin here, it becomes 1. And 1 compared with 0, it becomes 1. And 1 compared with 0, it becomes 1. Plus the coin here, it becomes 2. 2 compared with 1, it becomes 2. And 2 also compared with 1, it becomes 2 here. And 0 compared with no cell here, it becomes 0. And 0 compared with 1, it will become 1. And 1 compared with 1, it will become 1. 1 compared with 1 compared with 2, it will become 2. Plus the coin here, it becomes 3. 3 compared with 2, it becomes 3. 3 compared with 2, it becomes 3. Plus the coin here, it will become 4. So 0 compared with no cell here, it becomes 0. 0 compared with 1, it will become 1. 1 compared with 1, it will become 1. Plus the coin here, it becomes 2. 2 compared with 3, it becomes 3. 3 compared with 3, it will also become 3. And 3 compared with 4, it becomes 4. Plus the coin here, it becomes 5. And 0 compared with no cell here, it becomes 0. Plus the coin here, it becomes 1. 1 compared with 1, it becomes 1. 1 compared with 2, it becomes 2. 2 compared with 3, it becomes 3. 3 compared with 3, it becomes 3. Plus the coin here, it becomes 4. 4 compared with 5, it becomes 5. Cool. Also, okay, then we finish. This is the maximum number of coins that robot could collect. Okay, the 5 indicate that at the 5 at the bottom indicate that the total value robot could collect by moving from the top to the bottom. Okay, now we need to make a path for the robot. Need to follow. Okay, and then we start from the bottom and we compare the value as before. Okay, 5 here. We start from here. And 5 compare with 4, so it becomes 5. So we need to mirror like this so that the robot will follow from the top to the bottom. Okay, and then we are here. 4 compare with 3, it becomes 4. So we coming from the top. So 3 compare with 2, it becomes 3. So we coming from the left. Okay, like this. And here 3 compared with 2 also become 3. So we coming from the left. So here 2 compared with 1 it becomes 2. So we be coming from the above. Then here 0 compared with 1 it becomes 1. So we coming from the left. So here 1 compared with 0 it become 1. So here. And then 0 compared with 0 we break the tiles, so we go up. And then the last one is here. Okay, and next, this is the sample algorithm of the robot calculation problem. Okay, that's all from me, and we will proceed for the next part.
Assalamualaikum, my name is Noatika, and this is the real life example. The example that we can give is the grass cutting machine. To ensure that the long lawn is neatly trimmed, the machine will move either straight or right to make sure that the lawn is cut orderly.
In conclusion, this concept of dynamic problem is very simple to understand. The hardest part is to identify whether the problem can be dynamically solved, and if this problem can be solved, what the subproblem will be. Standard dynamic programming algorithm is where to finding total number of possible solutions and need to find the solution which maximum or minimum number of coins that can be collecting ending.